So very good morning, my dear friends. So yesterday I completed the torsion, you have completed, and you have studied the last at the end of the lecture. Variation of the torsional shear stress you have studied. The small correction is required. All of you can check the torsional shear stress variation of hollow circular shaft. Probably I made a small mistake here. Hollow circular shaft. In hurry, what I made at the end of the lecture, small correction is required. Are written like this now. Probably check it, you are written this now. But torsional shear stress proportional to corresponding radius. So the numerator should be capital D and denominator should be small d. So this is incorrect. So make this as what now? In place of maximum shear stress, make this as what now? Minimum shear stress. So make a small correction now. The ratio of the minimum torsional shear stress to maximum torsional shear stress is diameter ratio. That is what now? Inner diameter to outer diameter. Hollow circular shaft. Sometimes this is a standard question will be there. Torsional shear stress at inner radius of hollow circular shaft under pure torsion. Determine maximum torsional shear stress maximum shear angle assume so torsional shear stress at inner radius of hollow circular shaft under pure torsion is 60. Determine the maximum torsional shear stress, maximum shear angle, angle of twist of this shaft. Default angle of twist means you have to calculate the maximum. Under pure torsion, always angle of twist maximum at the free end. G, 100 gigapascal diameter ratio, length of the. Now what this diameter ratio 2 means, it is the outer to inner. It is the outer to inner, therefore it will be 1 by K. It is the 1 by K. Diameter ratio less than 1 means is a K. So it's a simple question, directly vote now. So maximum torsional shear stress to minimum torsional shear stress. It's the ratio of capital D by small d. So this ratio is given as. So maximum will be so this is 60. So it is the 120 megapascals. It varies from minimum to maximum. Then what about the maximum shear angle? Maximum shear angle, tau max upon G. The last one is angle of twist. Phi max equal to r theta upon L. So theta will be so 1.2 L is 1 meter. Now in this case, radius is required now. R0 is required for this calculation. R0 is required. So for this question, R0 is required. Assume inner radius is 50. Inner radius is 50 means outer radius is 100. So to calculate this one, radius is required. So make a small correction, already mentioned starting. Probably at the end of the lecture, I written tau max by tau min. It is not tau max by tau minimum, it is tau minimum by tau max. So I'm not giving the answers. Yesterday when I given somebody what, actually the answer key should be uploaded at the end of the subject now. When asked to technical team to upload that key to the evening batch, that English prime batch, by mistake they have uploaded that key for your batch also. So generally the key will be uploaded at the end of the subject, but by mistake in your batch is already uploaded 2 or 3 days back now. So when yesterday I given, some friends have already mentioned, sir, already keys uploaded. So we already cross check the answers now. The first question answer will be C. But first question answer is C. If anybody has what in this equation, what is given now? For this question, this is a GATE 2006 question. The year was not mentioned, GATE 2006. This question, some students are going to make a mistake, sir, we are not getting the answer. For this question, if a student is thorough with the concept, directly can give it now, without any calculation. 3 students, 3 ways they are going. 1 student without any calculation. Directly the answer is 100 because of both the shafts are same diameter and subjected to same twisting moment. In both the shaft, which is different now? Length is different, material is different. Length is different, material is different. But what you have studied now? Any stress on the cross section, is independent of the material, is directly proportional to corresponding load, inversely proportional to cross sectional dimensions. So in both the case, torque is same, diameter same. So directly can give the answer is going to be 100. Starting a clearly mention stress on the cross section, that is axial, bending, torsional shear, direct shear. They're all independent of the material. They are directly proportional to corresponding load, inversely proportional to cross-sectional dimensions. In both the case, torque is same, diameter is same. So directly the answer is what now? In both the shaft, stress is same now. So answer will be 100 megapascals. So this only what now? Using the what now? Who is going to do like this? He is going in the right direction. That is what it will become a flywheel. But second friend is going to use the tau max equation, T by ZP. He can use it, but it may take some time now. 1 minute or less than 1 minute now. But some students are going to use the GR theta by L. Sir, in the question G is given, R is given, theta is a theta, L is given. They are going to the GR theta by L. But those who are in the GR theta by L, they are going to get the incorrect answer. Some students are going to get a correct answer, but they are going to waste their time. If you the gr theta by L, in the question theta is not given now. So some students are going to assume the same theta. If torque is same, means theta is not same. So whoever is in the gr theta by L, first what they has to calculate now? Theta has to calculate it now. First they has to calculate the theta, then you have to substitute it. That's why I clearly mentioned yesterday what now? You have to do the T by ZP when torque is given. Gr theta by L, you have to use it when theta is given. In this question torque is given, then better to use the T by ZP, that is 16T by pi d cube. Sir, I want to use the gr theta by L, sir. You can use it. But chance of committing the mistakes are more. Some students are going to assume the what now? In the question thetas are not mentioned now. Then some students are going to be what now? They will assume when torque is same, in the theta is not given, they will assume the suitable data. So in the question torque is not given, so torque is given, theta is not given, they will assume the same theta. Torques are same means thetas are not same, and vice versa. If the thetas are same means torques are not same. So those whoever want to use the gr theta by L, most of they are getting the incorrect answer. No, they are not, sir, none of the options are matching now. Because they are going to cancel out the thetas. They will assume that both the shaft thetas are same. But thetas are unequal. So if you want to use the gr theta by L, first you have to calculate the theta by using TL by GJ. By using TL by GJ. Then that theta you have to substitute in that equation. Then you will get the correct answer. So first student is going to directly give the answer without any calculation. You will remember simply conclusion is what the sir you have mentioned. Stress on the cross section proportional to corresponding load inversely proportional to corresponding geometrical property or cross sectional dimensions. So in both the case torque is same, sir, diameter same, then answer will be directly 100. So without any calculation. Second friend is going to use the T by ZP. You will get the answer, but it's going to tell you the T by ZP, gr theta by L is going to use, or finally you will do the T by ZP. Then you may take 1 minute time like that now. But third friend is what a gr theta by L. Whoever is the gr theta by L, first problem is they are going to get the incorrect answer. They will assume the thetas are same. And second problem is they may get the correct answer, but they have to waste their time. First you have to calculate the theta, then you have to substitute the 2 times you have to do that question. First you have to find out the theta equal to TL by GJ, and that theta should be substituted in the tau max equation. How to calculate the who is mentioning now? If you know the maximum shear stress, I can calculate the outer radius. How to calculate? None of the radius is given now. How you will calculate, my dear friend? Who is that now? Rajanshu. How will you calculate, my dear friend? If maximum shear stress is what now? What is the maximum shear stress now? How will you calculate, my dear friend? Torque is not given in the question. Only K is given. T is unknown, D is unknown. How will you calculate the capital D? Before what now? Writing something on the live chat now. Please check it now. Directly I will not give it now. Sir, maximum shear stress, then why you have to assume now? Check it now. Before sending your query, please try it. Don't try it, simply tell it now. Have you tried that question now? Sir, maximum shear stress given. Why you are assuming, sir? I will get the outer radius directly. How will you get the outer radius now? But the torque is given. Torque is unknown. This also unknown. This also unknown. Two unknowns. How will you calculate now? So by chance the torque is given, you can find out the outer diameter. In the question, torque is not there. That's why I given what now? Inner radius I given now. Please don't send directly now. Please don't directly type your query on the live chat. If you are getting what, if you are sending something, first you try it now. Why the sir is given like this now? Mr. Rajanshu, Sir, why you are assuming this one, sir? I am getting the outer radius directly. How will you get the outer radius now? Maximum shear stress is known, sir. But where is the torque now? You know everything. You know everything. Spend some time. Sir has given inner radius. Y has given. We can calculate the what. First you put your question. Whatever the question you are asking the teacher, you ask that question for yourself on your own before asking the teacher now. You know everything. Believe yourself. Sir has given. Why sir is given? Try yourself. You know the answer. You have to try your side on your side now. After discussing everything now, teacher is here now. But when you are doing your preparation, teacher is not available now. Then at that time, whose help you are going to take it now? Teacher is not available, friend is not available. You have to take your help only. So make a always what now? Whenever you are getting any question, first put the question instead of to the teacher or the friend. First put that question to yourself. You already what now? Believe yourself. You are a talented, you are a unique person. You know the answer. Trust. First send your question to your mind. So you will get the answer now. And some students are asking first question, sir, why G is given, sir? Why L is given, sir? To create a confusion only. To create a confusion only. In your university examination, insufficient data is given and is asked to assume suitable data. But GATE paper, every data is given. ESC paper also, they will give the every data now. Every data, there is no scope for assumption. Sometimes they will give the extra data. Sometimes they are going to give the extra data. So you need not assume anything and you need not use each and every data to create a confusion. If that L and G is not given, then directly everybody is going for the T by ZP only. That's why clearly, please go through the class notes. Clearly written now. T by ZP and GR theta. But T by ZP should be used better when torque is given. GR theta by L is the best when theta is given now. If anybody want to go for the equations, which one I have to use? Now, this should be used now. But most of students, they will not use this now. They will use the what now? In the question G is given, L is given, they will use this now. They will use this equation. Then they will land into the problems now. They will use this equation. Theta is not given now. Then automatically what now? We will assume the suitable data. University examination, what we will do it now? Wherever data is missing now, we will assume some suitable data. That only mention the university examination now. Note, all the dimensions are in mm. Assume suitable data wherever necessary. So they will use the equation. Theta is not given. So they will assume the thetas are same. Theta is not same. So better to use this equation. But sir, I want to try with this equation, but I am not getting now. If you are not getting what, use any equation, answer should be the same. If you are not getting the same answer, means somewhere you have done a mistake now. And somebody will ask now, sir, you have mentioned stress is independent of the material, sir. Here is the independent of the material, but it is depend upon the material, sir. But what the theta? Theta is what now? TL by GJ. What you are getting now? G will get cancelled out. L will get cancelled out. Then what you are getting now? TR by J. So once again, the T by ZP only. सर ने आपने गलत कंक्लूजन लिखा दिया था सर. Stress independent of the material बोल के लिखा था सर. Either directly depend upon the material, sir. But I mentioned what now? When load is given. But here what is given? Theta is given. Always theta is not known. Always load is known. And you can check it now. In place of theta, substitute the TL by. Are getting the same equation or not? So then why you are written both now? This is better when theta is given now. This is better when theta is given. Directly substitute it now. This is better when torque is given. Can you use this equation when theta is given? You can use it. If theta is given in the question, you can use it. But first what you have to do it now? First you have to find out the torque. But torque is unknown. How to find out the torque? Now by using theta equal to TL by GJ. First you have to find out the torque, then you have to substitute it. Similarly, this equation you can also use it when torque is given. But first you have to calculate the torque. How to find out the torque now? The theta you have to calculate. When torque is given, how to find out the theta now? TL by GJ. So you can use any equation, but this is better when torque is given. This is better when theta is given. Use any equation, you will get the same answer now. But for this question, none of them are required. Directly what now? Stress on the cross section directly proportional to corresponding load, inversely proportional to cross sectional dimensions. In both the case, load is same, diameter same. They were directly answer is C. Question number 2. Question number 2 answer is A. But option D. When option D is correct now. In this question what is given now? Diameters are same. Same diameter is given. Then answer will be what now? In the question is asking what now? Hollow to solid is asking. Hollow to solid. Then ratio should be less than 1. So for option A within the bracket you write down now. Option A within the bracket. T hollow to T solid. Question number 2. Option A write down like this now. It is the ratio of option D. Option A is correct because it's asking hollow to solid. But when option D is correct now. Solid to hollow. But most of students they have selected T by 16 by 15. So please go through the question thoroughly. What he has given and what you have to solve it. Try to understand it now. So answer will be A, but D is also correct when TS to TH. Third question. Directly can give the answer. In the third question, what is given now? Theta is given. Then you have to go for GR theta by L. Third question, which equation you have to use it now? Third question, you have to use this equation. First question, if anybody want to use it, this should be used. First question, this is better because torque is given. Third question, which one you have to use it now? Theta is given. Third question, this is better. First question, better to, if you want to use T by ZP. But third question, theta is given. So better to use this equation now. In both the question, what? Theta is same, G is same, L is same, and radius is also same. Both the shafts are having what? The same radius. So answer will be 1. Go through the what? A question thoroughly. Every question they are not going to give the diagrams will not be given now. In both the question, what is given now? Maximum shear stress on solid shaft of diameter D, length L, twisted through angle theta is a tau. So solid shaft, what is given? Diameter is capital D, theta is given, length is given as L. A hollow shaft of same material, G is same length, having outside diameter, once again D. So in both the case, what now? Diameters are same, theta is same, material is same, L is same. Then answer will be directly equal now. Who is getting the doubt now? Somebody is what? I stuck in what now? Prakar. Question number 3. What is the doubt, my dear friend? Please go through the question clearly. I written on the notes now. This is better when theta is given. In both the case, what now? Is a solid shaft. Hollow shaft, what you have tried down now? Clearly what is given now? G is same, theta is same, L is same, and here diameter is D, capital D. Here also outer diameter is capital D. So directly answer is same. Both the shapes case, what? Answer will be same. Question number 4, directly can get it. Theta is asking TL by GJ. Answer is D. Question number 2 is A. Question number 3 is what? Delhi. Question number 4 is also Delhi. Question number 5 is also Delhi. 16. Directly can get it from this now. From this now. First you have to find out the hollow. How to find out the maximum now? How to find out the maximum? 16t by pi d cube. 16t by pi d cube 1 minus k to the power of 4. Then how to find out the tau minimum? Now by using the ratios. Sixth question, first use the what now? Tau max equal to gr naught g r naught theta upon L. But in the question theta is not given, torque is given. Then what the equation now? 32 TL by, first use the 16t pi d cube 1 minus k to the power of 4. This is the maximum shear stress. Then how to find out the minimum shear stress? By using the ratio. First you have to use the equation. T is given, D naught cube is given, diameter ratio is given. How to find out the other one? No? Minimum by using the ratio. Ratio of the diameters. So answer is B. So remaining questions you can get it directly. 13 is given as what now? Torsional stiffness. Gj upon L. Knowing the equation, not a criterion. Should know the equation. Go for the equation if compulsory. If necessary, then only go for the right equation. So should know before using the equation whether this equation compulsory or not. If it's compulsory, go for the equation. Then if the two equations are going to be there now, when you have to use the better now, it can be calculated two ways. This is the better when torque is given. First question is the better. Third question is the better now. What the question number 33 answer now? What is given question number 3? The 33. For the prismatic shaft shown in the figure, the maximum tensile stress at point A on the surface of the shaft. Point A is given on the surface. That is the critical point. On the surface you are getting what now? Torsional shear stress is maximum. So pure torsion, pure shear state of stress, under pure shear state of stress, under pure shear state of stress, maximum tensile, maximum compressive, maximum shear stress are going to be equal. This already has discussed the principal stress chapter, already done it now. And somewhere the point is given. So it is a pure torsion. So what is the twistment value now? 2pH. And what is asked the question now? Maximum tensile stress at point A on the surface. Maximum tensile stress at point A. Everybody is going to take the what now? 0 now. But it is asking at a point, and this point is under pure shear state of stress. Then the pure shear state of stress. Under pure shear state of stress, what you have studied now? This is nothing but about on the periphery only, on the surface. Which one the critical point you have studied in the pure torsion? Any point on the complete surface is a critical point. Yesterday at the end of the lecture you have studied now. You are getting a pure torsional shear, that is what a pure shear state of stress. Sigma x 0, sigma y 0, tau x y equal tau. Then you have studied about a maximum tensile, maximum compressive, maximum shear stress, all are equal. So at point A, so what the T value is given now? Because of so many questions you have done it now. Already in the principal stress already have done it, but diagram is given, that's all now. But what are the maximum tensile stress on the cross section? Maximum tensile in the cross section is 0. If you ask on the cross section, answer is 0. But it's mentioned at a point. You have to consider each and every plane now. Question number 21, find out the torque, my dear friend. Use the twist section method. How many sections are required now? 3 sections. You have studied same now. When you are studying the twistment sign convention now. Find out the twistment AB, twistment BC and twistment CD. It is not a pure torsion. So you have to find out the twistment AB, BC and CD. Take the 3 sections. 3 sections. Then find out the maximum twistment. Maximum twistment is the larger of twistment in AB, BC and CD. And that divided by what now? Pi d cube. 16 T max upon pi d cube. And question number 27 directly can give the answer now. Question number 27. Question number 27, without any calculation, you can tell it now. This only yesterday I explained now. This question only most of the solution they have given the incorrect answer now. It was a GATE civil engineering paper. Is asking at this point M. At the point M, what the tau xy at point M? What is what now? Sir, in the periphery they have taken 16 TB, but he is not asking the maximum torsional shear stress. He is asking tau xy. Here what the cross section Z phase? This is the cross section. So cross section of which phase? No, Z phase. So torsional shear stress will become as what now? Either tau zx or tau zy. The cross section Z phase, and Z phase how many shear stress are there now? Tau zx and tau zy. But in the question is asking tau xy, so answer is what? 0. Hence tau t max either tau zx or tau t max will become as what? Either tau zx or tau zy. But in the question is asking tau xy, and Z phase you will not get it what? Z phase how many shear stress are there now? One is the tau zx and tau zy. So torsional shear stress what? Tau zx and tau zy. But in the question is asking tau xy, the answer is directly 0. Directly answer is 0. But if you ask tau zx and tau zy, in the question is asked what now? Tau zx or tau zy. Then you have to see it now. The cross section is given like this. Why 0 means what the answer now? Tau t max will become as either tau zx or tau zy. But is asking tau xy directly 0. But if you ask what the tau zx or tau zy, if you ask tau zx or tau zy, then you need the what now? Which point now? This point is given here now. Point is given here now. This which phase now? Z. And this given as y. And this given as x. So what the torsional shear stress here now? Is it anti-clockwise, clockwise now? Anti-clockwise, then it should be tau zy. So at this point M, what the maximum torsional shear stress now? Tau zy or tau zx? Suppose we ask here now. If you ask what the tau zx, what the answer now? 0. But here what the torsional shear stress now? Tau zy. But at this point what the torsional shear stress now? So when this is required now, if you ask tau zx and tau z, but if you ask tau xy directly, answer 0. So write down the answer is 0. When this option is correct now, if you ask directly torsional shear stress, and this will become as what? A tau zy. Tau zy. If you ask the tau zy, answer is what? This now. But if the point is given here now, then it should be tau zx. But for this question directly can give the answer is what? A 0. So when the option C is correct now, option C is correct if you ask at point M, what the tau zy, at point M, tau zy, this will be the answer. Or otherwise, what the maximum torsional shear stress is the answer now. But if the question is asking what? The tau xy. So this is representing what now? Here how many shear stress are 0? Tau xy 0. Next. At this point M now, only tau zy is there. Only tau zy is there. Tau zy means what now? Tau yz is also non-zero. So which stress are 0 now? Tau xy 0, tau yx 0, tau xz 0, tau zx 0. Most of they are not gone through the question. Sir, point M is a torsion, therefore torsional shear stress maximum. But go through the question, is not asking the maximum torsional shear stress. Is asking tau xy. And this point is on what? X phase. Sir, Z phase. On Z phase there is no tau xy. Z phase you are going to get either tau zx or tau zy will be there. So answer is what now? Who knows this one? Directly what now? Answer is 0. Without any thought process, those here thought directly can give us 0. On Z phase there is no tau xy. Therefore answer is 0. If you ask tau zy or tau zx, then you have to check it all this thing. Same thing at point, suppose this I call the N. At this point N, yesterday I written at this point, which stress are 0 now? Tau xy 0 at point N. some questions what the concept oriented will be there. Somebody is going to do all this thing now. This is not compulsory. Blindly only what the answer now. Cross section at Z face. On Z face, how many shear stress are there? Tau Zx and tau Zy. But in the question is asking tau x, but the answer is directly 0. You don't need all this thing now. That's why what some questions are completely concept oriented will be there now. But some students are going to waste all this thing now. When these are all required now, if we ask tau zy or tau zx, if by chance in the question is asked what now, tau zy or tau zx, then you have to check it now. Then you draw this now. Then this will become the tau zy, this will become the tau zx. So many times I mentioned gate exam is about now test for concepts. Yesterday I had taken the x face. Yesterday I had taken the polar axis x face. Polar axis is what? X. That's the longitude axis. Polar axis is the longitude axis. Your longitude axis coincides with what? A z. So cross section z face. Yesterday I had taken the x. So cross section will become a x face. Then torsional shear stress will become as what now? Either tau xy or tau xz will be. If I had taken the x face, then torsional shear stress will become as either tau xy or tau xz will be there now. Tau xy or tau xz will be there. Most of students, they will use the 16t by pi d cube. And for that one is going to spend the 2 minutes time. Is wasting time and finally get the incorrect answer. But a student thorough with the concept without wasting time directly get the correct answer. So try to understand the question. Option A is correct for this question. But when option C is correct now, for the same question now, if you ask maximum torsional shear stress or what the tau zy, option A, C is correct now. Both that only mention most of the times more than one option is correct now. Now if the same question is given now, same question is given when a shaft is under for this now, for the shaft as shown in the figure, for the shaft as shown in the figure, A is also correct, C is also correct. This is representing what now? Tau xy and tau xz. And this is representing what? A maximum torsional shear stress. Sometimes they will make it as a MSQ question also. Previously MCQ was not there. That I already mentioned, only 2021 is introduced the MSQ. You might already done it. You might have already done it. Most of might have already done it. Your answers might have already matched. Then you check it now. Which approach you have used? I done the 4 or 5 questions. Which approach you have used it? So remember what us in GATE examination, only answer is correct answer, not the criterion. Which is the criterion? Correct answer and time, both are correct, both are important. Getting the answer is not a correct, getting the correct answer not a criterion. getting the correct answer within a less time, that is the criterion. You want to get a successful in the GATE 2023 and ESC 2023. You should get the correct answer within a less time. So time is very, very important. So when you are solving the question, suppose if you are getting the answer, you got it, and you taken 5 minutes time. Then you have to check it. It is given for 2 marks question, 1 mark question. Is there any other way to solve this question? Can I cut down the time? You have to do all this thing. But every question you cannot do it now. That's why you should be thorough with all the possible methods. Everybody is going to tell about a GATE 2023. Sir, paper is very easy, sir. Sir, without attending the medicine classes also we can do the paper. But how many marks you'll get it? Sir, I'll get only 60. Without attending the medicine lectures, you can do it. But why you are not getting 90 or 80? Sir, I know everything, sir. But sufficient time is not given, sir. They have given very lengthy questions, sir. But I know everything. You know everything, but you are unable to complete within the given time. Means you are done about now. You are not selected right method now. You are not selected right method. And somebody is getting 80 marks means what now? He has done the what now? All the questions correctly within a less time. Most of students, they will happy when they are solving now. Sir, I got the answer. Option A is what? My answer is matched with given answer key. But they will not check how much time they have taken now. So after solving the question, if your answer matches with A, correct answer, check it. How much time you have taken? Is there any other way of getting the answer? Is there any other way of getting the answer? Can I cut down this time? Further, can I cut down? That you have to do it. If you do all this thing, then only in the final, these are all practice papers now, practice now. So when you are making a practice the questions now, you have to do all this now. Otherwise, simply getting the answer is not a criterion, they will not be successful. 100% you will not get a success. This year what most of students are telling about now, paper is very lengthy, sir. But so many students have got the what now? 80 or 90 marks they got it now. How they got it now? Paper is what lengthy, but they got the 80 or 90 marks now. Means they have selected the what a right method now. Every question they have used, they are not use the equation. Don't run behind the equations. If necessary, then only go for the equations now. Each and every half minute or 1 minute it makes a difference now. So what about the question number 24? Question number 24, everybody is going to make a mistake now. Question number 24. What is given now? Shaft subjected to simultaneous action of torque T, bendment M, axial thrust. Axial thrust means what now? Compressive load. Thrust load is about a compressive load. Your thrust load is about now? Thrust force means the axial compressive load. Which of the following statements are correct? Shaft is subjected to an axial compressive load, a twisting moment and a bending moment. Which one of the correct now? But the first statement is given now. One extreme end of the vertical diameter fiber is subjected to maximum compressive stress. One extreme end. Now these questions, now once you know this, now then you can complete the remaining questions now. Now you have completed axial stress variation, bending stress variation, torsional shear stress variation. Now the questions of the what? The principal stress chapter which are pending, that you can complete it now. Now anybody can tell which one is the critical points here now. Which one are the critical points? So what should be the first step now? First you have to identify the what now? Principal stress should be calculated the critical point. But the first step we have studied now, critical cross section. Which one in a prismatic member? In a prismatic member, which one the critical cross section? At which cross section axial load, shear force, bending, twisting is maximum now? Is a prismatic member. Now where axial load, shear force and bending and twisting are maximum, how many loads are possible now? ALD is possible, BMD is possible, TMD is possible. What the shape of the ALD? Negative rectangle. What the shape of the BMD? Shape of the BMD is what now? Positive rectangle. And what the shape of the torque diagram? Positive rectangle. When axial loads are applied at the extreme end, when axial loads are applied at the extreme end, axial load is a constant. When twisting couples are applied at the extreme end, twisting is a constant. When bending couples are applied at the extreme end, bending is a constant. So here what now? Diameter is same, axial load is constant, bending is constant, twisting is constant. Every cross section is critical. So by chance a constant point load is applied like this now. When by chance a constant point load is applied now, then bending will vary. In place of this M now, if a constant point load is applied, what happens now? Shear force a constant, bending is going to be maximum here now. Then the critical cross section will be fixed end now. But here every cross section is critical. First you have to draw the loading diagrams. How many loads are possible here? How many reactions now? When axial loads are applied at the extreme end, axial load is a constant. When bending couples are applied at the extreme end, bend moment is constant. When twisting couples are applied at the extreme end, twist moment is constant. So what is the shape of the ALD? Negative rectangle. What is the shape of the BMD? Positive rectangle. And what is the shape of the torque diagram? Otherwise take a section. If you take a section here now, what is the axial load? Minus F. What is the axial load? Minus F, constant. What is the bend moment? Now plus M. What is the twist moment now? This is what a semi-closed ellipse. Anti-clockwise, I mean double arrow is going to be towards right. Is it negative? Either you can draw the diagram or otherwise take a section method. Is independent of x, means ALD is a rectangle. What is the shear force? 0. To get a shear force, one constant point load is required. And bending moment plus M is a sagging constant independent of x. And twisting moment minus T. So all are rectangle. All are rectangle means what? Every cross section load is same. Means every cross section is critical. Every cross section is critical. So you can take any cross section, you can take it. Now you can take any cross section. Is a negative rectangle. SFD is about now. Is the line coincide 0. Coinciding with 0. BMD is about now. Positive rectangle. TMD is a negative rectangle. But by chance, if a constant point load is given in place of this M now, in place of M, if a constant point load is given, then what you are going to get now? Shear force equal to plus W. And what the bend moment? W into X. Then in that case, which one the critical cross section fixed into the critical cross section? In place of this M now, if a constant point load is given, what the shear force now? Plus W. But what the bend moment you are going to get it now? Minus WX. Mean bend moment is what? A varying. So where the bend moment is maximum here now. In that case, every cross section not a critical, but here every cross section is critical. Now, then after taking the critical cross, now I'm assuming this is a critical cross section. You can take any one. Now next, what you have to do is a critical point. Critical point. Which is the critical point? What you have studied now? On a cross section, how many loads are possible? 4. How many stress are going to be there now? One axial stress, one bending stress, one torsional shear stress, one direct shear stress. So which one the critical point? at which point resultant normal stress, that is the resultant of axial and bending, and which point resultant of torsional shear and direct shear, but which stress 0 no? Direct shear stress 0. So on the cross section, how many stress are possible now? Next, you have to see the critical point is the point. These are in the CP. Critical point is the point where resultant normal stress that is and resultant shear stress. Is maximum. But in our case, what happens now? Which stress 0? No, direct shear stress 0, because there is no shear force. Now we are going to get only tau T max. Now where the torsional shear maximum? Periphery. Torsional shear maximum at the periphery. But where this is the axial stress there, due to axial load you are going to get an axial stress. Due to bendment you are going to get a bending stress. Where the axial stress maximum, everywhere the axial stress same. Axial stress uniformly distributed. At any point on the cross section, axial stress same. But where the bending stress maximum now? Bending stress maximum is a vertical bending. Default is about a vertical bending. So where the bending stress maximum here and here now? At every point axial stress compressive or tensile? Compressive. At every point axial stress compressive. But bending stress is what now? Maximum. Where it is maximum? Top and bottom. But already axial stress compressive or tensile? Compressive. Now I have to see the bending stress compressive. Where the bending stress compressive? Is it sagging or hogging? No. Sagging. Due to sagging, where you are going to compress the stress at the top. So which one the critical point? This is a critical point. So this is what now? What the resultant normal stress here now? Minus sigma A. And this is what the sigma X. Axial stress compressive. Bending stress also going to be compressive. But what about the bottom resultant normal stress? What the resultant normal stress? Axial stress what a compressive, but bending stress is going to be a tensile. What the resultant normal stress here now? Minus sigma A plus sigma B max. Minus sigma A plus sigma B max. But resultant positive or negative we don't know. Then what about the torsional shear stress? Here axial stress what a compressive. Same thing, how to write down the resultants the bottom now? Minus sigma A plus sigma B max. Minus sigma A plus sigma B max. So resultant normal stress maximum where is the top. And where the torsional shear maximum at any point now? At any point. At any point on the periphery. Already normal stress maximum at the top. And here already torsional shear is also the maximum. Then which one is the critical point? Out of all the points, this is the critical point. Suppose if there is no axial stress. If there is no axial stress or no axial load, if there is no axial load, which one are the critical point? Bending stress maximum at the top and bottom. Torsional shear stress are maximum at the top and bottom. No? Torsional maximum at every point, but bending stress maximum at the top and bottom. In that case, which one are the critical point? Both top and bottom are critical. If only axial load is there, if only axial load is there, which one are the critical point? Every point is a critical point. If only bend moment is there, which one are the critical point? Top and bottom. If only twist moment is there, which one are the critical point? Any point on the periphery. Any point on the periphery. Now if axial load and bend moment are acting, if axial load and bend moment are acting, then you are getting only axial stress and bending stress. Now which one is the critical? This point is the critical. If only bend moment is there, which one are the critical? Top and bottom now. But if axial load and bend moment are acting, either top or bottom, but here a top, because of what? Axial load is a compressive load. Bending stress is also compressive. And if axial load and twist moment are acting, if axial load and twist moment are acting, axial stress everywhere is same, but torsional shear stress maximum. Now which one are the critical point? Any point on the periphery is a critical point. But if bending moment and twist moment acting, bending moment and twist moment acting, which one are the critical point? Top and bottom. Now if all are acting, axial load and bend moment and twist moment acting, this is a critical point. So what the torsional shear stress here now is anti-clockwise, clockwise now. So your torsional shear stress like this. So this will become a tau. So this point is a critical point. Now can you find out the principal stress now? Can you find out the principal stress? How many stress are there now? One normal stress and one shear stress is there now. One normal stress and one shear stress. So what is the state of stress at this point now? If I take a cube now. If I take a cube, is a cross section. This is resultant normal stress, compressive, resultant normal stress. This is sigma x. This is taken the what now? This is a cross section. This is tau xz. Is a critical point. Is a cross section. This here taken Z. This here taken Y. Here taken Y, and this is X. So this is Z face. This is X face. X face. and this is y phase. Bending stress what a compressive, like this compressive. Already what you have said, always axial and bending stress on the cross section will become as what? Dot and cross. Axial and bending stress always in which direction? No? Polar axis direction, x direction. What you have stated, axial and bending stress variation can be seen in a plane perpendicular to plane of cross section. On the cross section they will become as a dot and cross. On the cross section they will become as a dot and cross. But is a cross or what? Cross or a dot now? Cross because of compressive. So what this stress now? This is sigma x. Somebody, sir, you are not taken minus. Because already the compressive only is a compressive. And this is torsional shear stress. Now this will become as what now? Tau. One will become as a tau xz, one will become as a tau zx. This is tau zx. This is tau xz. Now can you find out the principal stress? So what the principal stress equation now? 1 by 2 sigma x plus, now I have to consider which phase now, x and z. We have taken x and y. Then you have written the principal stress. When you have taken the x and z, what the principal stress? X and z, how many independent components now? Sigma x, sigma z and tau xz. X and z, x and y phase, what the independent component now? Sigma x, sigma y, tau xy. X and z, what the independent component? Sigma x, sigma z, tau xz. Sigma x, sigma z is 0, sigma z is 0, only tau xz. So what the principal stress equation here now? 1 by 2 sigma x plus sigma z, but sigma z is 0, plus or minus square root of sigma x minus sigma z whole square, plus 4 tau xz square. In place of sigma x, what should I put it now? In place of sigma x, what should I put it now? 4p by pi d square plus 32 m by pi d cube. This is a 4p by pi d square, this is a 32 m by pi d cube, but compressive. So what is overall value now? Minus of 4p by pi d square minus of 4p by pi d square plus 32 m by pi d cube. Sigma z is 0. And what the tau xz? What the tau xz? 16t by pi d cube. Then you can find out the principal stresses now. But somebody, what if you ask here now? If you ask here, what change you are going to get? Anybody here now? Sometimes they will ask clearly here now. Here which stress 0? Bending stress 0. Is a vertical bending. These are neutral axis. Here bending stress 0. Bending stress 0. Then only which stress there now? Axial stress and torsional shear stress. So what change you have to make it now? Sigma x is what? The only axial stress. Bending stress 0 at this point now. Here you are getting only axial stress. Bending stress 0 because this point is on the neutral axis. When bend is acting alone, it is a neutral axis. Only axial stress is there. So what change you have to make? And torsional shear stress will become as what? Torsional shear stress become as what? Tau xz or tau yz now. Tau xy. Here torsional shear stress what now? Tau xy. Like this now. Tau xy. Then in that case, which phase I have to consider now? X and y phase you have to consider. So here what the principal stress now? Sigma x is the axial stress. And what the tau xy? 16t by pi d cube. And here which one is 0 now? Sigma y 0. But if you consider here, what happens now? Axial stress is a compressive, but bending stress is a tensile. So what the sigma x value now? Minus sigma a plus sigma b max. At this point, what the sigma x now? Sigma x is what? The minus sigma a plus sigma b max. That's why you need all the variations now. at T means top, sigma x is that is minus 4p by pi d square minus 32m by pi d cube sigma z0 and tau xz tau t max. Then you can calculate the principal stress at point T. If we ask F is what now? Is on the HCA. Is a vertical bending. Under vertical bending, this will become the neutral axis here, bending stress 0. So at F, what change I have to make it now? Sigma x equal to minus sigma A. Sigma y 0. Torsional shear stress is what now? And I have to consider which phase now? X and Y. Torsional shear stress is what now? Torsional shear stress become as tau xy. Then I have to consider the X and Y phase. Otherwise, I will take this point now. At F, what the sigma x now? Because bending stress 0. Sigma y 0 tau xy tau t max now you can find out the principal stresses once again now. So point to point what the principal stresses are going to be changes, but default where you have to calculate the critical point, which is the critical point. This is a critical point here because axial resultant normal stress and resultant shear stress maximum critical point. Now once again you can calculate the principal stress here now. What the state of stress here now? And here you are going to get it. This is tau t max, but this will become as what a tau xy. This is tau yx. This is tau yx and this is tau xy. Suppose if you ask at the bottom what change you have to make it now? At bottom what change you have to make it now? Bending sagging case, bending the bottom is a tensile. So what change you have to make it now? Minus sigma A plus sigma B max. Remaining is same now. At bottom, So like this, what the point to point, the principal stress are going to be changes. So it is not possible to calculate. That's why you have to do the analysis at the critical point. So if you ask in this question, principal stresses means maximum tensile and maximum compressive means you have to calculate at a T. That's the critical point. Anybody want? If you ask here now, at centroid, what the state of stress? At centroid, bending stress 0, torsional shear 0. At C, at the centroid, bending stress 0, torsional 0. Only which stress is there? Axial stress. Then you are going to get a uniaxial state of stress. At C, so problem to problem critical point is changes. If only axial load is acting alone, which one are the critical point? Every point is a critical point on that cross section. If only bending is there, which one are the critical now? Only vertical bending, which one are the critical point? Top and bottom are critical. If only twist is acting, any point on the cross periphery is the critical point. Next combination, axial load and bendment both are acting. Either top or bottom. That depends upon the axial load and bendment now. In our case, which one the critical now? Suppose if the twistment is 0, which one the critical point now? If the twistment is 0, which one the critical point? Only top is the critical point. If twistment is 0, only the top is the critical point. So if I change this is what? Hogging. If I change this hogging, so which one the critical point now? Bottom will be a critical point. In place of this is what now? Sagging. If I take an hogging, then what the bottom now? Hogging. Minus sigma A and minus sigma B max. Hogging case, bottom is a compressive. So if I change this now, bottom is a critical. That is what now? When axial load and bendment both are acting. Which one are the critical now? Either top or bottom. Default I am taking the what now? Vertical bending only I am taking now. Either top or bottom. Suppose the horizontal bending. Bendment is in horizontal plane and axial load are there. At that time, which one are the critical now? Either extreme left or extreme right is critical. When bendment is in horizontal plane and when axial loads are there. At that time, either extreme left or extreme right is going to be critical. Next, what the other combination now? Bendment and twistment acting now. Bendment is maximum at the top and bottom. Torsional shear is maximum at any point on the periphery. In that case, which one are the critical now? Both top and bottom are critical. Next, what the other combination now? Axial load and twistment acting. Which one are the critical point? Any point on the periphery is critical because axial stress everywhere is same. Torsional shear is maximum at any point on the periphery. When axial load and twistment is acting, any point on the periphery is critical. But when axial load and bendment are acting, which one are the critical? Either top or bottom. But when axial load and twistment acting, which one are the critical? Any point on the periphery is critical. Next, for the last combination now. Axial load, bendment and twistment. Once again, which one are the critical now? Only one point, either top or bottom. So how many combinations are there now? Axial load and bendment and twistment, axial load and twistment, and all these loads. That's why this type of questions are not discussed in the principal stress chapter, because for this one we need axial stress variation, bending stress variation, torsional shear stress variation. But default everywhere I am taking the what? The vertical bending. Suppose the horizontal bending is there, then the point is going to be changes now. Sometimes they will ask the question now. If nothing is mentioned, you have to calculate the critical point. Nothing is mentioned, you have to calculate the critical point only. So overall, which one are the critical point in this now? Overall, which one are the critical point? On this cross section, the top is critical, but every cross section is critical. I have taken up only one cross section. On this cross section, this is critical. Like this, how many cross sections are there? Infinite. On every cross section, which one the critical point top? So these are all the critical point for this given case now. All these are critical. If you ask only on cross section, top is a critical. But if you ask the entire bar now, which one are the critical? Any point on the top surface is critical. Any point on the top surface is critical. Any point on the top surface. Therefore, you should be careful whether they are asking the member or a cross section. Cross section means top is a critical. But why every? Because all the cross section are critical. Already what you have written. Everywhere diameter is same. Everywhere axial load is same. Bend moment is same. Twist moment is same. Suppose if the constant point load is there, if a constant point load is there, which one the critical cross section here now? In this case, which one is the critical point here now? Is the critical point, sir, critical cross section. Now you have to do analysis here only. Then how many stress are here possible now? Here how many diagrams are possible? ALD is possible, BMD is possible, SFD is possible, TMD is possible. What the ALD? Negative rectangle. BMD is about a triangle. SFD is about a rectangle. Torque diagram is a rectangle. So which one the critical cross section? This is the critical cross section. Clearly mentioned critical cross section, the cross section where axial load, shear force, bend moment and twist moment is maximum. Then after identifying the critical cross section, you have to see the what now? On every cross section, how many stress are there now? 2 normal stress, 2 shear stress. Then which is the critical point? At which point resultant of normal stress and resultant of shear stress is maximum. Resultant of normal stress and resultant of shear stress maximum. That is the resultant of axial and bending, resultant of direct shear and torsional shear max. That is the critical point. So if somebody will ask now where you are going to the analysis means critical point. How to decide a critical point? What is the first step now? Sir, we have to draw the loading diagrams. Then critical cross section, the cross section where axial load, shear force, bend moment and twist moment is maximum. Then on that cross section you have to see at which point resultant of axial and bending, resultant of torsional shear and direct shear stress is maximum. At that point you have to take a small elemental cube, then you have to find out the what is the sigma x, what is the sigma y, sigma z, tau x y, tau x z, that you have to find out. Then there you have to find out the principal stress. But sometimes clearly they are mentioning the point. If nothing is mentioned, if you ask a member means always you have to do the at critical point you have to do the calculations, you have to do it. If you ask whenever by maximum tensile, maximum compressive, maximum shear stress, maximum tensile, maximum compressive, maximum shear stress in the member means you have to calculate at a critical point. At point B, why can you take the sigma y, my dear friend? Torsional shear is becoming a xz. How can you take the sigma y? At point B, what the torsional shear stress now? Tau xz or tau xy? At point B, torsional shear stress is going to be tau xz. Then you have to take the xz face now. At point B, you have to take the xz face. But at this 2 point, what the torsional shear stress is xy direction. Then you have to take the what now? Here x and y face. Here x and y face. But top and bottom what happens? The torsional shear is tau xz. Then you have to take the x and z face, x and z face. At the top and bottom, you have to take the x and z face. At extreme left and right, what should I take it now? Torsional shears become as a tau xy. Then you have to take the x and y face you have to consider now. Supreet Kumar. Once I am repeating now. First, you have to draw the in a prismatic member. Critical cross section is the cross section where axial load, shear force, bendiment and twistment are maximum. For that one, first you draw the ALD, SFD, BMD, TMD. Otherwise, take a section, write down the equations now. Write down the axial load equation, shear force equation, bendiment equation and twistment. Draw the ALD, SFD, BMD, TMD. Then you see at which cross section all these loads are maximum. So after identifying the critical cross section, on a cross section infinite points are there. On a cross section maximum stress are 4, 2 normal, 2 shear. Then you have to see at which point resultant normal stress, that is the resultant of axial and bending. Resultant of axial and bending. Then resultant shear stress, that is the resultant of torsional shear and direct shear. So critical point is the point where sigma r, that is the resultant normal stress and resultant shear stress maximum. At that point you have to do the stress analysis should be done it. That is at that point you have to find out the principal stress. Once you know principal stress, you know the maximum shear stress. So whenever it asks in a member, find out the maximum tensile, maximum compressive, maximum shear stress in a member, means you have to do at a critical point. But what about the sigma A, sigma B, tau D, tau T max now? What is the drawback of all this equation? What's the drawback of this equation? These are all on the cross sections. All these equations give a in a member on a cross section. These equations should be used if we ask on a cross section. P by A the area of cross section. M by Z, Z is the section modulus of cross section. T by ZP, polar section. So what is the drawback of this equation? These equations will give the maximum stress only on the cross section. So whenever we ask a member, we cannot use this equation now. Maximum stress in a member means you have to go for the maximum stress in a member means you have to go for the principal stress calculation. So if somebody will ask now, what is the necessity of principal stress? Because these equation will give only maximum stress on the cross section. Axial stress due to axial load. Axial load is what now? Normal load on a cross section passes the centroid. This is about a bending stress due to bendiment. Bendiment is about now algebraic sum of the couples and moments on the cross section. These are all about on the cross section only. That's why I can see in a denominator area taking here P by A. A is the area of cross section. M by Z. Z is about now section modulus of the cross section. So these are all going to be the only on the cross section. But whenever you ask in a member, then you have to do the principal stress calculation. For that one, you have to do the stress analysis. For that one, you have to do the stress, and that is where you draw the stress tensor or state of stress should be drawn it now. Now see the question number 24. So the remaining questions you have to do it now. You know already axial stress, bending stress and principal stress calculations already know. So the principal stress chapter remaining questions you have to complete based upon this now. Question number 24. What is given now? The same question now. Subjected twistement, bendiment and axial compressive load. So by chance is a tensile load. By chance is a tensile load. Then which one is the critical now? Due to tensile load, axial load the tensile, everywhere the stress is tensile. Then you have to see the bending stress. Where the bending stress is tensile in case of sagging now. If this is a tensile load. In this case, if I taken a compressive load, which is the critical point? Top. But if I taken a bottom, this load is a tensile load, axial tensile load. Everywhere the axial stress is tensile, and due to sagging, where you are going to get a bending stress na bottom. So which one is the critical point na? Bottom is the critical point. If by chance is a tensile load, critical points are what? Any point on the bottom surface, any point on the bottom surface. Then what the value you have to write down here now? Sigma x equal to sigma a plus sigma b max. Because axial load is a positive, bendiment is also going to be positive. Now you can see this now. What the first statement is given now? One extreme end of the vertical diameter fiber subjected to maximum compressive stress only. This is about now. One extreme end of the, this is called as the vertical diameter fiber. Vertical diameter fiber. One extreme end of the vertical diameter fiber. One extreme end means what now? Maybe a top or bottom subjected to maximum compressive stress. When you'll get only this compressive stress, means this should become 0. When this will become 0 now? Twist limit is 0. So when the option A is correct now, when the option A is correct now, option A is correct when axial load and bendiment both are acting simultaneously. What you have studied, when axial load and bendiment are acting, which one are the critical point? Either top or bottom, either top or bottom, but default I am using the vertical bending. So first statement write down within the bracket now. First statement write down within the bracket. Option A is correct. When axial compressive load and bendiment are acting simultaneously. Option A. Statement option A is correct. When axial compressive load and bendiment are acting simultaneously. Next, what the second statement is given now? Opposite extreme end of vertical diameter fiber subjected to opposite extreme end of the vertical diameter fiber subjected to tensile or compressive. When this is possible now? Tensile and compressive. When bendiment is acting alone. When bendiment is acting alone, what happens now? Which one are the critical points? When bendiment is acting alone, vertical bending. Which one are the critical point? Top and bottom. That write down now. When vertical bendment acting alone, what happens? The top is going to be about a tensile, bottom is a compressive. If you take a sagging, top is a compressive, maximus minus sigma B max. Bottom is about a plus sigma B max. So second statement, write down now. Option B is correct. Option B is correct. Under pure bending. Under pure bending. That is when bendment is acting alone. Option B is correct when bendment is acting alone. That is under pure bending. Next, what about the last third one now? Every point on the surface of the shaft subjected to maximum shear stress. When you are going to get every point on the surface, you will get a maximum shear stress, pure torsion. When you are going to get every point on the periphery, only torsional shear stress now. Only you are getting a shear stress now. But you are getting axial stress there, bending is there. But when you are getting only shear stress now, pure torsion. So write down the third one. Third one is correct under pure torsion. Third one is correct under pure torsion. Pure torsion. And what the last one now? Axial longitudinal fiber. What is the meaning of axial longitudinal? Longitudinal axis. Axial longitudinal fiber of the shaft is subjected to compressive stress. At the centroid, which stress you have studied, only axial stress. Bending and torsion is 0. Now at each and every point, which stress 0 now? Bending stress 0, torsional. Only which stress is there now? Axial stress. So for this given question, which statement is correct now? Option D is correct now. For the given question, option D is correct now. Everybody is going to ask what the axial longitudinal fiber means. Longitudinal axis. At the longitudinal axis is what now? Imagine line joining the centroids of each and every cross section. At the centroid, bending stress 0, torsional shear 0. So for this given question, option D is correct now. Now you can see now, A is also correct, B is also correct, C is also correct, D is correct. But A is correct when compressive load and bendment are acting simultaneously. Second statement is correct when bendment is acting alone. Third statement is correct when twistment is acting alone. But when all are acting, which one are the critical point? All are acting simultaneously. Critical point is about top or bottom. Either top or bottom. But in our case, I am getting top because of compressive load. If it is a tensile load, bottom is a critical. So for this given question, this is one of the engineering service paper. Most of the solution they have given the incorrect answer now. But somebody is given about the solution, they are going to give the option D. It is going to ask, sir, how D is correct now? So you should know. And this question may be once again may be possible for the MSQ. Question will be like this now. Which of the following statements are correct? Which of the following statement is or are correct? Extreme, top or bottom. Extreme, top or bottom are critical points when bendment is acting alone. Extreme top or bottom are critical point when bendment is acting alone. Statement is incorrect now. But the statement is correct what now? When both axial load and bendment acting simultaneously. Next. Extreme top and bottom are critical. Extreme top and bottom are critical when axial load and bendment both are acting simultaneously. Once again, the incorrect now. extreme top and bottom are critical only when they are correct now. When only bend with the acting alone. When bend with the acting alone. And every point on the cross section is critical on the pure torsion. Every point on the cross section is critical point. Is a pure torsion. Incorrect now. Pure torsion, which one are the critical points? Any point on the periphery is a critical point. Next, last one is when axial load, shear force, bendiment and twist. When axial load, either extreme top or extreme bottom is the critical point. When axial load, bendiment, twistment acting simultaneously. This statement is the correct. Extreme top and bottom. Top or bottom is a critical point when axial load, bendiment and twistment acting simultaneously. Somebody will ask, sir, आपने workbook questions नहीं किया था sir. Which are directly substitution that I am not spending. Everything I have given now. Which are formula substitution. Why should I? Now this is what nobody asked now. But I explained. But here my presence is required now. All the 4 statements are going to be correct now. But most of them are going to be what now? They will identify the option D. Suppose today that answer key is not uploaded now. Everybody will ask this question now. But today nobody asked this question. Why? Because they know the answer, that's all. Once you know the answer, they will not, once answer is known, our thought process will not work now. Because in front of us, what a key is there now. That's why I will not upload. By mistake, what the technical team is uploaded that key now. If by chance this key was not uploaded in your batch now, definitely so many students will ask this question now. Sir, how D is correct, sir? If I am going to give the, somebody will give the what now? Give the answer means, sir, A, B, C, D, all are going to be there now. But when answer is there, what now? If they don't get it, simply see the answer now. They will see the what now. No, most of them, they didn't understand this question now. But they have seen the answer key. Sir has given D. Then they will try to identify it now. Sir is given answer D means, then they will try to how to find out that answer. In the exam, answers are not going to be given. You have to do it, analysis, and you have to identify it now. That's the drawback of what now? When the answer key is available. First day itself, everybody is going to ask now. Sir, upload the answer key. That is the drawback. I am going to be what? I can save the time. If I am going to upload the workbook key now, I can save my time. But you are going to be the losers now. Because human being mentality is what now? Human being mentality is what now? When already answer is known, our thought process will not work now. We'll see that question. Why should I try? Already answer key is available. Well, let me check it. D. Then based upon that one, answer is given D. Then they will try to what? Somehow they will try to find out that answer now. My suggestion is what now? Please don't refer what now? That key. Whenever I am giving the questions, please don't refer that workbook key, whatever is uploaded. Try on your own. Try on your own. Try to write down. Next day I am going to give the answers. Then you check it. Otherwise, first you try it. Then you can check that answer key. Please don't see that answer key. What is the not correct, Preetham Jyoti? आपने बोला था not correct. Which is not correct? Not correct बोलो तो क्या समझना है? Simply not correct means what should I understood now? I'm going to repeat these statements. Previously I already repeated. Cross check it now. In a horizontal member, when axial load is acting alone, every point on the cross section is critical. When axial load acting alone, every point on the cross section is critical, because axial stress everywhere is what the same. Next, second statement. Under pure vertical bending, under pure vertical bending, critical points are the points lying on top and bottom fibers, or otherwise pure vertical bending. Any point on the extreme top fiber, any point on the extreme bottom fiber are critical under pure vertical bending. Any point on the top fiber, any point on the bottom fiber are the critical. Default, I am assuming the water centroid is exactly the mid depth. But under pure horizontal bending, any point on the extreme backside or front fiber are critical. Under pure horizontal bending, any point on the extreme backside fiber or front fiber, are critical. Next, under pure torsion, any point on the periphery of the cross section, are the critical points. Under pure torsion, any point on the periphery of the cross section are critical. Next, we are going for a combination. When axial load and bendiment and vertical bendiment means what? Bendiment in vertical plane. When axial load and vertical bendiment are acting simultaneously, critical points are the any point on the extreme top or extreme bottom. Next, when axial load and horizontal bendiment acting alone, any point on the extreme backside or any point of the extreme backside fiber or front fiber are critical. Next, when axial load and twistment is acting alone, any point on the periphery are the critical point. Next, when vertical bendiment and twistment acting simultaneously, any point on the extreme top fiber or slightly changes. When vertical bendiment and twistment acting simultaneously, any point on the extreme top fiber and bottom fiber both. When vertical bendiment and twistment acting simultaneously, any point on the extreme top fiber and bottom fiber are critical points. Next, twistment and horizontal bendiment acting simultaneously. Any point on the extreme backside fiber, extreme front fiber are critical. Extreme backside and front fiber are critical when horizontal bendiment. Last, when axial load, twistment and vertical bendiment acting simultaneously. Axial load, twistment and vertical bendiment acting simultaneously. Any point on the extreme top or any point of the extreme bottom are critical. Next, when axial load and twistment and horizontal bendment acting simultaneously, any point on the extreme backside or any point on the extreme front fiber are critical. Any point on the extreme front fiber are critical. Now, can anybody tell here which one is the critical point? In this case, which one is the critical point? If you ask the principal stress, at which point you have to do it now? Which one is the critical point? It is equal to how many loads now? One eccentric axial tensile load and one twisting couple. One twisting couple. So it is equal to how many loads now? Anybody can give the answer quick. Which one are the critical points? Which one are the critical points in this case? Critical points are only B, only T and B dash. This B is what? A backside. Since both are B, I differentiate. B dash means bottom. B is on the backside. This B is on the back side, this is the top, this is on the front fiber, this is what now? Is the front side, this is what now? On bottom. Only B, only T and B dash, B and F and only F. Only this is the answer now. Most of the friends has given now. But somebody has taken top and bottom. How is the top and bottom now? This is equal to what now? Axial load and giving a bend between which plane? A horizontal plane. It is giving a bend between horizontal plane. This is equal to how many loads you are going to get it now? One axial load, tensile load and a bending moment. Bending moment in which plane now? Horizontal plane. Therefore the Cx or Cy or Cz. This is what now? Cy. Cy. Due to axial load everywhere, what now? You can put it now. Axial load is the tensile or compressive? Tensile. Therefore it is what now? P by A. P by A plus. And what about the bending now? This bending is in which plane? Horizontal plane. Is coming on the front side or back side now? Is coming on the front side. Either clockwise or anti-clockwise? No, either clockwise. Coming on the front side, front contraction. So front what now? Stress is what now? Couple is what? Coming on the front side. So bending stress what? Maximum where now? At front and back. Bending stress maximum, front maximum contraction, back side is maximum elongation. So this will become the neutral axis. So here bending stress 0, bending stress 0. Here bending stress what? A tensile or compressive? Tensile. And here is going to be compressive. Coming on the front side is the horizontal plane. So now can you write down the bending stress at the top? 0. Front plus M by Z. Z about which axis now? ZYY. ZYY. B dash 0. Back side, so this is a compressive, and this is so what about the resultant normal stress? The both can be added. What the resultant stress now? P by A, and this is P by A minus M by ZYY. here P by A. At all the point torsional shear stress maximum T by ZP. At which point now direct shear stress 0. So this itself will become as about the resultant shear stress because of direct shear stress 0. Now at which point you are getting maximum now? Everywhere resultant shear stress same, but resultant normal stress maximum at the back side now. So this is a critical point. Now this stress will become as what? The sigma x or sigma y now? Is the normal stress. Normal stress. Always this in which direction? Polar axis. Which is the polar axis you have taken x. So this stress will become as what? The sigma x. Sigma x. This is sigma x. Sigma x. All are sigma x. But what about the torsional shear stress? Torsional shear stress. What the torsional shear stress at the top? Torsional shear stress what now? What the direction of torsional shear stress? Tau xz or xy now? This is what? Tau xz. At front. Y. Tau xz. This is tau xy. Tau xy. Cross section is like this. This is which one you have taken? Z. This is Y. This twisting couple is the clockwise, anti-clockwise. Twisting couple is the clockwise. Twisting couple is the clockwise. So it will be so this will become about a tau xz. But what about these 2 points now? This will become as what now? And here this is what the sigma x. Here axial and bending stress tensile. Bending about tensile means so this will become as what a sigma x. But here we are getting only tensile. This is what the value now. This will be what the sigma A plus sigma B max. But here only this is a neutral axis. Here bending stress 0. Here we are getting only axial stress. Here only axial. But here and here what now? Is the backside, extreme backside now. Backside. T F so how many stress is there now? Tau xy is there and sigma x. What is the sigma x value now? But here only axial because this is a neutral axis. Here bending stress 0 because couple is in a horizontal. So many times I mentioned now. Neutral axis will coincide with the HCA in case of when bend made is in vertical plane. When bend made is in horizontal plane, neutral axis simply directly what this couple is about which axis? Y axis. So YY will become the neutral axis. What do you mention now? How to identify the neutral axis? Neutral axis bending stress 0. How to identify the neutral axis? Couple is acting about which axis? Y. So this will be the neutral. Therefore, you have bending stress 0. You can easily identify the neutral axis. At the neutral axis, bending stress 0. How to identify the neutral axis? Couple is acting about which axis now? This bending couple is acting about y, horizontal plane, y. So here bending completely what on this line, bending stress 0. But bending stress maximum here now. But this coming on which side now? Front side. Front contraction. Therefore here what should I write down now? Sigma A minus sigma B max. Here only axial stress. Here only axial stress. That only I shown it now. But everywhere these all the point torsional shear maximum only. But this is because tau xz. Either tau xy, tau xy, tau xz will be there now. They're all anti-clockwise because this couple is a clockwise. So now can you find out the principal stress now? How to find out the principal stress now? What the principal stress is here now? Default you have to calculate the critical point. 1/2 sigma x plus or minus but what the sigma x value now? 4p by pi d square 32 m. What the bendment value now? Load into eccentricity. What the eccentricity now? Bendment value is p into d by 2. Eccentricity d by 2. And what about tau xy? Okay, good, no problem. I know because everybody is given points only. They are not given options, they are given only points only given now. Good. But this question, 100% I can tell it now. 70% of students are going to make a mistake. 70% who is not attended my lecture now. Because in all the textbook they are mentioning this is a neutral axis. They will take the bending stress maximum here, they are going to take it. Because in all the strengthometer textbook they are mentioning the what now? Neutral axis HCA. You ask 100 students, 70 students are going to tell about a bending stress maximum at the top and bottom now. Because in all the textbook they are dealing with the beams. Beams are what? A vertical bending. That's why what the most of the case they are going to mention the what now? Critical points are T and B dash they are going to mention. Critical points are what? Only B. Only B. How you have decided the critical point? What do you have mentioned now? Critical point is a point where resultant normal stress, resultant shear stress maximum. Resultant normal stress means resultant of these two. Sigma A plus sigma B max. And how to find out the resultant? Is it what now? Always what the normals in the cross section. Axial and bending. Bendings are always in the polar axis. Here which is the polar axis? You have taken X. So blindly what now? Axial and bending stress. Sigma X or sigma Y or sigma Z. So many times I mentioned now when you made a comparison also. Axial and bending stress are always in the direction of the polar axis. In the direction of the polar axis. Here which is the polar axis? X. And what about the torsional shear stress? Here torsional shear stress in which direction? HCA direction. Here in which direction? VCA direction. Here HCA, here VCA. So at this point is the tau xz, at this point is the tau xy. But if you ask what the principal stress at F, if you ask the principal stress at F, what change I have to make it now? I have to put it minus 4p by pi d square minus. That's why starting clearly mention. Always moment of inertia section modulus should be considered about a central axis which is perpendicular to the plane of cross section, plane of the couple. You are bending couple in which plane now? Horizontal plane coming on the front side. So remaining is what? Simply numericals only. What is going to be given in the question? P is going to be given, diameter is given. You can do all the calculation now. Now you can do some numerical data. You can take it and find out the principal stress now. Determine maximum, sorry, if P is 50 kilonewtons and D is so P value is given, D is given. Now you can do the calculations now. So this is what now. Determine maximum tensile and maximum shear stress on the cross section. Determine maximum tensile and maximum shear stress in the bar. First question is easy. What are the maximum tensiles on the cross section? On the cross section means what now? How many normal stresses are there? Axial and bending. So for this question, what the answer directly now? Sigma A plus sigma B max. And this is what directly maximum shear in the cross section means torsional shear stress. On the cross, this is eccentric axial load. How many load on the cross section now? It is eccentric axial load. How many load on the cross section now? One axial load, one bendiment and one twistment. Then on the cross section you are getting three loads. One axial load, one bendiment and one twistment. Then you are getting one axial stress, one bending stress and one torsional shear stress. So which stress can be added? Axial and bending. So directly what the maximum tensiles in the cross section? Sigma A plus sigma B max. What the maximum shear stress on the cross section? 16T by pi d cube. But next question is what now? Maximum tensile, maximum shear stress in the bar. Then here you have to go for the principal stress calculation. But where you have to calculate the principal stresses now? Where you have to calculate the principal stress now? Critical point. Which is the critical point? What is the critical point now? Which was the critical point? Remember, blindly you can tell it now. Whenever a eccentric axial load is there, whenever a eccentric axial load is there, where the resultant normal stress maximum, see that load is near to which surface now? This load is what now? This is the top surface. This load is what? Eccentric axial tensile load. So whenever a eccentric axial tensile load blindly what now? Where the resultant normal stress maximum, the surface which is nearer now. So directly what? This is what? Nearer to top or bottom? Otherwise slightly I will change it. I am talking about now objective I am talking now. What is the actual method I have to do it now? You have to see the axial stress, bending stress. Then you have to see the where the resultant normal stress maximum, whether bending stress, where it is a tensile, where the bending stress is compressive. Instead of doing all this thing, so whenever about the eccentric axial load is there now, which type of load? The eccentric axial tensile load. What is the actual method now? First you have to put the axial load and bendiment, then you have to see the sagging, hogging, where the bending stress is what now? Is it about now? Bending, sorry, this bendiment is the vertical plane, horizontal plane. Then you have to see the what now? Where the bending stress tensile, where the bending stress compressive. You have to see. Instead of all, that is the actual method. Just now in the previous case. But here for objective examination, directly what you can do it now. See what this load is near to top surface or bottom. This line is the top surface. This line is the top surface. So directly resultant normal stress maximum at the top surface. So resultant normal stress, that is the resultant of axial and bending, always maximum where now? At a surface which is nearer to the load. At a surface which is nearer to the load. Since this load is nearer to top, therefore top surface. Directly, this is what now? Is which surface? No, top surface. So resultant stress on the top surface maximum. Then what you had is a tensile or compressive load? Is a tensile load. It is a tensile load. Therefore, it is going to be what? The axial stress is going to be a tensile. This is a tensile load. Axial stress is a tensile. Next, it's already a tensile. Then bending stress also should be tensile. Why now? Already a stress should be a maximum. Already axial stress is a tensile. Then this should become maximum, means I have to take the plus sigma B max or minus sigma B max. Plus sigma B max. So whenever a eccentric axial load is there, what is the first step now? See that line of action of the load. See the line of action of the load is nearer to which surface now? This load is near to top surface. So where the resultant normal stress is maximum. This is the top surface. Sigma r, resultant normal stress at the top surface is maximum. Then what is the next step now? See, this is a tensile or compressive? Tensile. Therefore axial is the tensile. Then bending stress, what? One side you are going to get a tensile, one side is a compressive. Actually you have to see the bendment direction is a sagging, hogging, that all you have to see it now. Instead of this one directly, what now? Here already the stress should be a maximum. This is already a tensile. Then automatically bending stress should be a tensile. Directly sigma A plus sigma B. By chance this is given as a compressive load. By chance this is given as a compressive load. What should I write down? Minus sigma A. And here it should be a maximum. Therefore it should be minus now. If this is a compressive load, it is a compressive load. Then minus sigma A and minus sigma B max. So without going for any direction, bending, couple, sagging, hogging, which surface contracted, which surface elongated. Once I am telling now, whenever a eccentric axial load question is given, the resultant normal stress maximum on the surface which is nearer to the load, which is nearer to the line of action of EAL. Since this load is near to top, therefore top surface stress is maximum. Then what is the next step now? See, this is what a tensile or compressive. Tensile plus sigma A. Then automatically bending stress should be a tensile. Since a plus sigma A plus sigma B. Suppose this is given as a compressive load. Minus sigma A and minus sigma B max. By chance the question is asked the bottom. Then bottom, what change I have to make it now? If you ask at the bottom, sigma A. Already there is tensile load. Therefore, axial stress everywhere is what now? Axial stress everywhere same nature, same like in nature now. What you have studied? Axial stress are what now? Like in nature. Top is a tensile, mean bottom is also tensile. But what about the bending stress? Top is a tensile, mean bottom is going to be a compressive. That's all. And top and bottom what now? Top and bottom what? Torsional shear stress maximum now. Now, so which one the critical point here? Now the top is the critical point. Top is the critical point. This is the top critical. And this stress about a tensile or compressive? Resultant is the tensile. If I have taken the X, dot means for the tensile sigma A plus sigma B max. What the use of this now? You can easily identify what now? Sigma. Next, what about the torsional shear stress? This twisting coupled with the anti-clockwise, clockwise. Twisting coupled with the anti-clockwise. Then resisting coupled is going to be clockwise. Then it should be like this now. This is what now? If I had taken this as Y, this is Z. Z. So this will become as tau xy. What the tau xy value now? Tau t max. At the bottom, what change I mentioned now? Sigma A minus sigma B max. So can you give me about now directly what the answer for the first question now? First question, what the answer now? It is M by Z. Section modulus pi d cube by 32. And what is bendment value now? Load into eccentricity. Every eccentric axial load, what is one axial load and bendment? What the bendment value now? Load into eccentricity. Now everything is given. You can complete this calculation now. Next. It is tau xy. Somebody can also take the tau xz also. If you take it here, what this will become a tau xz. I am writing about the critical point. This is what now? Tau xy. This is tau t max. 16t by pi d cube. Pi d cube. The twistment value is given in the question. You can complete it now. The first question. Next is asking what in the member. In the bar means what? You have to find out the principal stress. At which point you have to calculate the critical point. Which is the critical point? Top. At top, how many stress are there? No, sigma x and tau xy. Which stress 0? No, sigma y 0. So 1 by 2. What the state of stress at the top? At the what the state of stress? If you show the 2D, I taken this is what now? Now this line is about now x face or cross section. So this will be a sigma x. And torsional shifts to the clockwise. Now they are not the here principal stress calculation compulsory. So this is only on X face. These are the maximum stress only on the X face. That is the cross section. What this figure representing now? State of stress at critical point, that is top. Either you can take a small elemental cube, otherwise 2D figure you can put it like this now. So your principal stress are unknown. Then this will when this will become the maximum stress now, when tau xy 0. When tau xy 0, this is a maximum stress now. When this will become the maximum shear stress, when sigma x 0. Suppose this is 0, this will become about a principal plane, then this will become the maximum normal stress. And when tau xy will become the maximum shear stress under when sigma x and sigma y 0. When sigma x 0, this is maximum shear stress in the member. When this is 0, this is the maximum tensile stress in the member. But when both are there, what now? Neither this is the principal plane nor tau max plane. Neither this is the principal plane nor tau max plane. Now I can complete it now. Somebody is going to ask what, sir, you have taken in plane tau max. Here both are same. Here more circle will intersect the x-axis, in more circle will intersect the y-axis. This case you have studied. More circle is what? Intersect the y-axis. What is the shape of the more circle for this now? Right side you are getting, this is what? For this case I have drawn the more circle now. What is the shape of the more circle for this now? So principal stresses are unlike in nature. And whenever a more circle intersect the y-axis, what you have studied now? Principal stresses are unlike in nature. In plane tau max and absolute tau max are same. So directly what? Absolute tau max and in plane tau max are same. Sigma 1 minus sigma 2 by 2. Both are equal now. So you are going to get about one is the tensile, one is the compressive, you are going to get it now. But most of students, if I ask the maximum shear stress in the bar, they will take this 16 T by pi d cube. 16 T by pi d cube is the maximum shear stress in the cross section. And what the first value is quick now. What the sigma x and tau xy? Sigma x and tau xy. So they are getting different values now. What the first value, my dear friend? First value 106.95. Check it. Other one is 29.37. 20.37. Your principal stresses are unlike in nature. One will be a positive, one is a negative. You are going to get it now. One is a positive and one is a negative. Your sound is okay. Give me these principal stress values. Anybody now? One you should get a positive, one is a negative. You're going to get it now. First value is a positive and second value are going to get a negative. One is a positive, one is a negative. One is a positive and one is a negative. See, your audio is okay. Somebody is not getting audio. Please check from your end now. Your audio is okay. Anybody, this calculation's quick. Sometimes they may ask about to find out the principal stress at the bottom. If you ask the principal stress at the bottom, means what I have to put it now? Sigma A minus sigma B max. Sigma 1 is 110.7. 100 and positive. And this is 3.7. Summation you should get it 106.95. So what is the maximum tensile stress in the bar? But if you ask the same question directly now, maximum tensile stress in the bar, everybody is going for this value now. But what is the maximum tensile in the bar now? 110.7. 110.7. So what is the answer for this question now? First question answers are and second question answer is I have to go for the unlike in what is this now? 110.7 plus 3.65. Check it, this we are getting check it okay, this calculations now. Most of the question they will ask maximum shear stress. 40% of student maximum shear stress means they will take 20.37. Now you can see what the maximum shears in the cross section, 20.37. But what the maximum shears in the bar now? 57.175. But where you are getting means what now? You have to look at the plane location. We are not calculating the plane location. But where you are getting means what? You have to go for the plane location. First method should I use it now? Maximum tensiles in the bar. Directly in the question they will ask maximum tensiles in the bar. 30% of students they will go for 106.95. If clearly mentioned principal stress they will do it now. If you ask the same question, determine the principal stress means everybody do the calculation. But if you ask this question now, determine the maximum tensiles and maximum shear stress. Everybody is going for these answers now. Maximum tensile stress means they will take the what now? Should be careful. On the cross section, when you are going to get a maximum normal stress, on the cross section, when you are going to get a maximum normal stress, if it is a principal plane, suppose this tau xy is 0, if tau xy is 0, the cross section will become as a principal plane, then this will become as the maximum tensile stress. If tau xy is 0, if twist limit is 0, then this is 0, then directly this plane is a principal plane, then this will become a maximum tensile stress. So on the cross section, you are going to get a maximum normal stress when there is no shear stress, that is when there is no twist limit and when there is no shear force. And when the cross section you are getting maximum shear stress, when the cross section will get a maximum shear stress when sigma x and sigma y 0. On the cross section you are going to get a maximum normal stress when tau xy is 0. Then the cross section becomes the principal plane. Always the maximum normal stress are possible on the principal plane. When the cross section will become the principal plane when tau xy is 0. Similarly, when the cross section you are getting a maximum shear stress, when the cross section will become the maximum shear stress when sigma x and sigma y 0. Normal stress maximum on the cross section when cross section a principal plane, that is what now? When direct shear stress and torsional shear 0, that is when shear force and bendment twistment are both are 0. When cross section becomes a principal plane, when cross section becomes when axial stress and bending stress both are 0. Because somebody is having the logo issue is going to be there. I'm writing here now. When axial stress, when cross section becomes that is axial and bending stress both are 0. When there is no axial load, and no bendiment on the cross section, when there is no axial load and no bendiment on the cross section means there is no normal stress on the cross section. Mean when sigma A, sigma B both are 0, that is when resultant normal stress 0, then the cross section will become the Tomax plane. Shear stress maximum on the cross section when cross section become as the Tomax plane. Cross section become as the Tomax plane when axial load and bend moment both are 0. Similarly, what now? Cross section become as what now? Principal plane. The normal stress become maximum. Normal stress become maximum. Normal stress maximum on the cross section when cross section becomes a principal plane. When the cross section becomes a principal plane means shear stress 0. How many shear stress in the cross section? Direct shear and torsional shear stress are 0. So these are the important one now. Whenever shear force and twist moment both are 0, whenever shear force and twist moment both are 0, cross section is directly a principal plane. Then on that cross section we are going to get a maximum normal stress. You are going to get it. Similarly, on the cross section you are getting a maximum shear stress when both axial load and bend moment both are 0. Maybe check it what I written what maybe some variation in the decimals. Be accurate in your calculation. I have taken some of your friend answers. I written check here now. So under pure axial loading, only axial load. So there is no shear force, no twist. Therefore directly on the cross section you are going to get a maximum normal stress. Pure bending, no shear force, no twistment. So directly on the cross section you are going to get a maximum normal stress. You are going to get it. Pure torsion, there is no axial load, no bending. Therefore on the pure torsion directly on the cross section you are going to get a maximum shear stress. Expression for maximum shear stress and principal stress. When circular shaft is under, when circular shaft is subjected to both bendment and twistment simultaneously. Expression for principal stress and maximum shear stress when circular shaft subjected to both bendment and twistment simultaneously. These are the very important equations. So many times the questions will be there now. And this is also required in your machine design as well as theories of failure. Because generally the shafts are subjected to both bendment and twistment. So in this case, which one are the critical points you have studied now? In this case, which one are the critical points? Any point on the top and bottom, both bendment and twistment acting now. Divide this bendment is in what? Vertical plane. Which one are the critical point? Any point on the top and bottom are the critical. Any point on the top and surface and the bottom surface are critical. So which one are the critical points? Which one are the critical points? Any point on the top surface, any point on the bottom surface are critical. Any point on the top and bottom surface are critical. So which one are the critical point? Both top and bottom are critical. Here. T by pi d cube. Somebody will ask why you are taking, sir, why you are taking the torsional shear stress only here? Why not here now? These points are not clear. Bending stress 0. Which one the critical point? Where resultant normal stress and resultant shear stress. But here how many normal stress? Only one normal stress. Bending stress and one shear stress. One torsional shear stress. Bending stress maximum at the top and bottom. But here torsional shear is maximum, but bending stress 0. Bending stress 0. And here you are going to get a bending stress compressive or tensile. The bending stress compressive. Compressive means cross mark. This is sigma x. Perpendicular sigma x. Blindly what the axial and bending stress are what now? In the direction of the pole. Which is the polar axis x. So it is a sigma B max. (32 m by pi cube). Here tensile. Dot means a tensile away. But if you take at these points, you are getting only, there is no bending stress, only torsional shear stress. Only tau xz. Bending stress 0 at this point now. Here bending stress 0 at this point. At this point bending stress 0. That is sigma x 0. So at this point you are getting only torsional shears because these are neutral axis because of vertical bending. So overall which one the critical point? Top and bottom. Anyone you can take it now. Top and bottom are critical points. Now can you find out the principal stresses now? Critical points are the any point on but if you ask, this is a cross section. If you ask on the cross section, what the maximum normal stress? 32 m by pi cube. But what the maximum shear stress? 16 t by pi cube. If you ask on the cross section, maximum normal stress is 32 m by pi cube. Maximum shear stress 16 t by pi cube. But in the bar means you have to go for the principal stress calculation. This figure representing only the cross section. Now I'm calculating at the bottom. I'm calculating now. I'm taking the bottom. I'm calculating. I'm taking about the bottom. Sir, I want to take the top. You can take it now. You'll get the same now. Equation will remain same. Principal stress equation will remain same now. I'm taking at the bottom. Because bottom what now? Now what the bottom now? Sigma x is (16 t by pi cube). 16 t by pi cube. Now you can find out the principal stresses now. If anybody want to show the state of stress, you can show like this. Bottom. This is And sometimes they will ask what the Mohr circle for the bottom. What the Mohr circle now? Mohr circle is a circle symmetric or unsymmetric about the origin. Unsymmetric. Right side will be there. This case only you discuss now. When you discuss the Mohr circle, I discuss this case now. The practical example, Mohr circle is going to be unsymmetric about the origin. Right side is one because this is going to be a tensile. It is intersect the both x and y axis. Now you can find out the principal stress now. Sir, I want to take the top. If you take the top, this is going to become as minus now. But final equation same now. 1/2 what the sigma x 32 m by pi cube sigma y 0 which sign is going to plus sign will give a sigma 1 or minus sign will give the sigma 1 plus sign because this value is more than m. So by taking the plus sign I am getting about now larger positive value, and by taking the negative sign I am going to get a negative value. They were the sigma 1 because this value is more than m. Sigma 1 means now principal stress are unlike in the positive, this is a negative. So once again in plane and absolute are equal. Absolute and in plane are equal. When the principal stress are unlike in nature, in plane and absolute are equal. Sigma 1 minus sigma 2 by 2. But what is the maximum shear stress in the cross section? 16T by pi d cube. But this value is what now? More than 16T by pi d cube or less than now? More than. What is the maximum shear stress on the cross section? 16T by pi d cube. On the cross section maximum shear stress 16T by pi d cube. But what is the maximum shear stress in the shaft now? More than this now. This value is what now? More than T or less than T? More than T. And what is the maximum tensile stress now? Maximum tensile stress is what? 32 m by pi d cube. Maximum tensile stress how much? 32 m by pi d cube on the cross section. But this value will be what? More than 32 m by pi d cube. But the equation valid when bend method acting or twist method acting or both are acting simultaneously. All the case I can use it now. Suppose the bend method acting alone, what I have to make it now? Twist method is 0. If a bend method acting alone means pure bending. Pure bending is a uniaxial state of stress. Only one principal stress is there now. If I make the T is equal to 0. Pure bending is a uniaxial state of stress. Only one principal stress is there now. Pure bending, what the state of stress? only uniaxial state of stress. This is when you are going to get now pure bending, you have studied the uniaxial. So directly what the sigma 1, sigma b max 32 m by pi d cube. But this value check it now more than 32 m by pi d cube. But if I make the twist limit is 0, if I make the twist limit is 0, what about this value now 32 m by pi d cube only? And this is 0. When I make the twist limit is 0, this will be 0. Here what the sigma 1, this is valid when pure bending, that is when bend limit acting alone. Sigma 1 equal to 32 m by pi d cube, sigma 2 0. And what the maximum shear stress here at now? Half of this now, half of this value now. Pure bending case you have studied now, this is 32 m by pi d cube. So for this case, what the sigma 1, 32 m by pi d cube, sigma 2 0, what the maximum shear stress? 16 m by pi d cube. Now you can check it now. Is it valid for pure bending or not? If I make the T 0, this is 32 m by pi d cube. If I make the T 0, this will become as 0. And if I make the T 0, this is 16 m by pi d cube. So this is similarly what now? Pure torsion, what the state of stress? Is a pure torsion. What the expression now? Under pure torsion, what you have studied now? Maximum tensile, maximum compressive, maximum shear stress are equal to tau T max 16 T by pi d cube. Now can I use this for pure torsion? Pure torsion means which one you have to make it 0 now? Bend limit is 0. If I make the m is equal to 0, what you are getting now? Pure torsion, you have studied the biaxial state of, so how many principles are there now? 2. Sigma 1 and sigma 2 equal and like. So now you can make that twist limit, bend limit is 0. Is a plus 16 T by pi d cube. If I make that twist limit is bend limit is 0, minus 16 T by pi d cube. If I make the bend limit is 0, 16 T by pi d cube. So when m is 0, what happens? All are equal. Sigma 1 is 16 T by pi d cube, sigma 2 is minus 16 T by pi d cube, and tau max is 16 T by pi d cube. So these equations are valid what now? When bend limit is acting alone or twist limit is acting alone or both are acting, all the case you can use it now. But they are compulsory in which case now? When bend limit and twist limit acting simultaneously. In this case directly can give it now. Uniaxial state of stress. Under uniaxial directly sigma 1 equal to sigma x, sigma 2 0. And what about the tau max? Sigma 1 by 2, uniaxial state of stress. Is a pure shear state of stress. Under pure shear state of stress, what you have studied now? Maximum tensile, maximum compressive, maximum shear stress are equal to tau T max. What the tau T max? 16 T by pi d cube. So this equation can be used for the pure bending, pure torsion, and both bend limit and twist limit acting simultaneously. But they are compulsory under when bend limit and twist limit acting simultaneously. In this case, you know principal stress directly, tau max is known. In this case also, you know the principal plane, principal stress and tau max. But in this case, it is a combined stress. In this case, combined stress. Therefore, here we don't know. Neither principal planes are known, nor tau max planes are known. But in this case, x and y face are the principal plane, diagonals are the tau max plane. And here x and y face are the what? Tau max planes, and diagonals are the principal plane. But if you ask the what now, you should be careful now. If you ask the final, these are what now? They're all in the bar. But the maximum shear stress in the shaft. Maximum shear stress in the shaft means this is the answer now. But maximum shear stress on the cross section is what now? 16 T by pi d cube. What the maximum shear stress in the cross section? 16 T by pi d cube. But maximum shear stress in the bar is what now? 16 by pi d cube square root of m square plus t square. Where you are going to get this value now? Maximum shear stress plane. Where the maximum shear stress plane will get it now? At an angle of 45 and 135 degrees to principal plane. At an angle of 45 and 135 degrees the principal plane. These are taken cross section, my dear friend. This is a cross section. Bending stress perpendicular to cross section. This is a cross section. This line is about a cross section. Here I am assuming this is a cross section. So what is the final conclusion now? If you ask this question now, what is the maximum tensile stress on the cross section? 32 m by pi d cube. Maximum compressive stress is 32 m by pi d cube. Maximum shear stress 16 t by pi d cube. But in the bar means you have to do all this thing now. And overall these equations are valid what now? When both bendment and twistment acting simultaneously, or when only bendment, only twistment. But they are compulsory when both are acting. When only bendment is acting, this is the state of stress. Directly can give the answer. Sigma 1 is 32 m by pi d cube, sigma 2 0, and tau max is about 16 m by pi d cube. When you have studied what now, bending equation are clearly written now. And the pure torsion, this is a pure torsion, pure bending. Here you know directly. Here these two are the tau max plane and diagonals are the principal plane. Here maximum tensile, maximum compressive, maximum shear all are equal. They are equal to 16 t by pi d cube. But here maximum tensile is 32 m by pi d cube. Maximum shear stress 16 m by pi d cube. Otherwise, if you want, you can use it now. These equations. Pure bending means you have to make the twistment 0. Pure torsion means pure bending means twistment 0. Pure torsion means m is 0. Check it now. Suppose axial load is also there. Just now you had done it. Suppose axial load is also given, which is the critical point. Bottom is the critical point. If axial load is there, what the critical point bottom? Then what should I write now? Sigma B max plus sigma A. 32 m by pi d cube plus 4p by pi d square. So here what change I have to make it now? 32 m by pi d cube plus 4p by pi d square. This is what now? When axial load 0. When axial load is also there, this is the critical point. Then what the sigma x now? 32 m by pi d cube plus 4p by pi d square. That also you can do it now. So you can easily remember these equations now. But they are all valid for solid circular or hollow circular. They are all valid for solid circular. We have taken a solid circular. Now what is the generalized equation now? Now this equation valid for any cross section. That is what now? Both solid circular, hollow circular, thin hollow. Just now you have taken a solid circular. Solid circular, what is the ZP? Pi d cube by 16. If I ask about the same question for thick halo, what the ZP now? Thick halo, what the ZP? Pi d cube by 16 into 1 minus k to the power of 4. And what the ZP for a thin circular? Pi d square by 2. So what the, this is valid for any circular cross section. When circular shaft is subjected to any circular shaft, means what? A solid circular, hollow circular, thin hollow. Both bendment and twistment simultaneously. Yesterday I already given this jet piece now. Thick circular. But mostly in the exam they are asking a solid circular. But by chance a hollow circular is given. All the textbook they are doing like this now. But some paper they are given hollow. Hollow also they are using this equation. So you can easily remember ZP already known now. So these are the generalized equation for principal stress and maximum shear stress. If nothing is mentioned, the maximum shear stress means in plane and absolute both are same. When any circular shaft subjected to both bendment and twistment simultaneously, please don't focus on the basics, my dear Mr. Supreet Kumar. Is a cross section. Both are perpendicular or not? It is a normal, this is a shear. Is a cross section. Is a normal stress, the shear stress. Both are mutually perpendicular only. These both are mutually perpendicular or not? Sir, both are what axial and bending stress, torsion. Both are perpendicular only. This is what the perpendicular. This is parallel. is the cross section. Where you can see this cross section of side view, you can see it now. I already shown the side view now. Use your drawing concept now. Sir, shear stress, normal stress in planes. How shear stress and normal stress are perpendicular planes, my dear friend? Shear stress and normal stress are, one is perpendicular plane, one is parallel plane. They are not what now? Sir, shear stress and normal stress in plane perpendicular to each other. पूरा सुनने के बाद ये पूछ रहा था आपने. What you are listening now? Normal stress perpendicular to plane, shear stress parallel to that plane. And is mentioning normal and shear stress are both are in two perpendicular planes. Who mentioned both are in perpendicular planes now? अब तक सो गया था क्या आपने? इतना बार पूरा पढ़ने के बाद आपने both are what of two perpendicular planes? This is what on perpendicular to this plane. This is parallel to this plane. That only normal stress. What is the meaning of normal stress? Perpendicular to given plane. Shear stress is parallel to given plane. Planes are not perpendicular. Normal stress and shear stress are what now? They are on the same plane only. One will be a perpendicular, one will be a parallel to the plane. This is a cross section. This is what a perpendicular to this now. They are on the same plane only, but one will be a perpendicular, one will be a parallel. They are not in perpendicular plane, my dear friend. For the same plane, that is which plane now? Cross section. For a cross section, one is acting perpendicular. This is acting perpendicular to this plane, and one is acting parallel. They are not in perpendicular plane now. For the same plane only. Oblique plane concept what you have studied now. This is a plane. This is a normal stress. They are on the same plane only. They are not in two perpendicular plane. This is perpendicular to this plane, this is a parallel to the plane. After studying and all this thing, you are asking what now? Is a plane. This will be a what now? Perpendicular plane. This is a normal stress, this is a parallel to plane. Each and everything I explained now. Now we are getting a doubt now. So now you can complete the remaining questions of the principal stress chapter. Now you can do all the questions of the principal stress chapter remaining now. So I'm going to give the question at the end. Remaining all the questions you can do it now. What is the value of the torque already given? No, initially I given, probably afterwards I removed this. Now probably I taken the Anybody want to check it? For the torque value is given now, 500 Newton meters. Previous numerical question now. Somebody is asking what the torque value now. Who is that now? Saket. I've already written. Maximum torque value is what? 500 Newton meters. 500 Newton meters. So now with this one, what the total chapter number 7 is completed. The total chapter number 7 is completed. And these are the important equations now. They can be used for the any cross section. So we'll take a break. Now it is 12:50. After break, I'm going to do some more questions on the torsion chapter. I've not done some questions. You all already done it. Some questions I'm going to do it. 1 or 2 questions then, so that all the concepts are going to be cleared now. Then we are going for the first chapter where you are going to do the bars in series in the parallel that you are going to discuss. Then we'll come to the SFD BMD now.